For this problem, we want to figure out tangent of 7 pi over 6 minus pi over 4. To do this, we're going to use the sum difference formula for tangent. Here, a is equal to 7 pi over 6, b is equal to pi over 4. So a good starting point would be, well, what is tangent at these two angles? So I'll start with tangent of 7 pi over 6. My reference angle is going to be pi over 6, and I know tangent of pi over 6 is 1 over the square root of 3. The only thing I have to be careful about is, will tangent be positive or negative? 7 pi over 6 is in the third quadrant, and therefore it's going to be positive. Tangent of pi over 4 is 1, and that's actually in the first quadrant where tangent is positive. Now that I have these two values, let's plug this information into this formula. And the first thing I'm going to note is, since we're taking a difference, I'm going to use the negative part of this, which means I'll have tangent A minus tangent of B, but then the denominator is going to be 1 plus tangent of A times tangent of B. So let's plug all of this in. So this is going to be tangent of 7 pi over 6 minus tangent of pi over 4. That's all divided by 1 plus, and then we'll have tangent of 7 pi over 6 multiplied to tangent of pi over 4. Since I've already evaluated tangent for these angles, I'm going to plug those numbers in. So tangent of 7 pi over 6, I'll just put 1 over root 3. I don't have to reference that it's positive again. And then I have minus tangent of pi over 4, which is minus 1. Next, okay, it's going to be 1 plus, again, tangent of pi over 6. 7 pi over 6 is 1 over root 3, and that's multiplied to tangent of pi over 4, which is 1. I don't really need those parentheses, so maybe I'll just rewrite this as this expression here. 1 times 1 over root 3 is simply 1 over root 3. Now, that is an answer, but it's just not simplified. Two problems I see. One, we have fractions within fractions, and ideally we would just want one fraction overall. The second thing is, I see I have this irrational number in the denominator. In fact, the entire denominator is irrational. Technically, a simplified answer would be written with a rational number in the denominator, if possible. To deal with the first problem, I'm going to multiply the top and bottom of this fraction by the square root of 3. By doing this, it's going to cancel the fractions that are within the fractions. So it's kind of a trick, but I'm multiplying this by 1, but I'm writing 1 as root 3 over root 3. Multiplying by this won't change the value of this expression because this technically equals 1, but when I distribute this root 3 into the numerator and then the denominator, it's going to cancel the fractions. So, for example, when I multiply root 3 to 1 over root 3 over root 3 is going to be equal to 1. So let's write this out. I'll continue my work over here. So that was root 3 multiplied to 1 over root 3 simplifies to 1. Then we have minus, and then this root 3 multiplied to this 1 is simply root 3. Okay, next, root 3 multiplied to this 1 is also root 3. And then root 3 multiplied to this fraction is root 3 over root 3, and that is equal to 1. So we're getting closer. But again, we still have this problem where the denominator is irrational. So the next thing I'm going to do is actually order the denominator so it's 1 first and the irrational number, root 3, second. I like to write it this way. So I'm changing the denominator to this. This is equivalent to my previous step. The reason for this is I'm going to do a trick. I'm going to multiply again by something that's equal to 1, which won't change the value of this expression, but what it will do is remove the irrational number from the denominator. Okay, and the thing that we're going to do for that is we look at the denominator, we change this positive to a negative, so we're making the value with the irrational number negative, and I'll put that over here. So I just basically looked at this thing. I saw it was positive root 3, and so I switched it to negative root 3. I'm going to put the very same thing in the numerator just to ensure that I'm multiplying by 1. This trick will rationalize our denominator. So it'll take a little bit of work to get there, but we're going to have to distribute the numerators and denominators out, combine like terms, and go from there. So to start with, okay, I'm going to take this 1 and multiply it to both terms over here. So 1 times 1 is 1. And then we get 1 times negative root 3, and so we get a negative root 3. Okay, next I multiply the negative root 3. Multiply to here gives me a second negative root 3. And then when I multiply this thing here, I have a negative times a negative, so it's positive. And root 3 times root 3 means square root 3. So this times this is 3. I'm going to do the same procedure for the denominator. I'm going to multiply 1 by 1, so we get 1. I'm going to multiply 1 by negative root 3, which will give me negative root 3. I'm going to multiply root 3 by positive 1, so I get a positive root 3. And lastly, I have a positive root 3 times a negative root 3, so we get a negative, but also the number 3. Before moving further, the reason for me writing the irrational number second and then switching it so it was negative over here instead of positive made this happen in the denominator. We got an integer and an integer at the ends of the expression, and the irrational numbers that appear in the middle, one's positive and one is negative, they cancel. This is why this trick works. What it does is when you multiply this stuff together, it's going to cancel your irrational numbers. So like this and this are gone. I'm going to go on to another slide, but essentially what I'm going to do is copy down this expression and simplify it as best I can. So after canceling these two terms, all that's left in the denominator is 1 minus 3. So I'm just going to write that down. I have a denominator, and it's 1 minus 3. Now, in the numerator, okay, here the irrational numbers don't cancel. That's okay. I have 1 plus 3, which gives me 4. I have minus. I have a negative root 3, a second one. So in total, I have minus 2 root 3. Getting there, but here we go. In the denominator, we have negative 2, and in the numerator, we have 4 minus 2 root 3. Okay, the last thing to do here is to note that you're dividing negative 2 into every term that appears in the numerator. If you divide negative 2 into 4, well, 2 goes into 4 twice, and the whole thing is going to be negative. So 4 divided by negative 2 is negative 2. If you divide negative 2 into negative 2 root 3, the negative divided by the negative becomes positive. 2 goes into 2 with 1 left over, which I won't write, and the root 3 remains. So this is it. This is the completely simplified answer for question 16.